Today we'll finish up section 8.3 and 8.4, just focusing again on what's really the critical stuff in the section. So, the last thing we left off with was writing complex numbers in trig form. Before, we've written numbers in standard form. This is standard form. A number plus or minus a number with I. Trig form is going to look more like, I'm just trying to find an example. We'll make one up as we go. I don't have a nice one to show you quick, but we're going to do one. All right, so in trig form, you don't have a real number plus or minus I and then an imaginary number. What you have are two things. You have an R and a theta. That's the key to writing a number in trig form. What R is it's the distance from your point that you graph to the origin. It's basically the absolute value. We talked about that. Theta is the angle in this triangle between the x-axis and the hypotenuse. You have to find those two things to write a number in trig form, and later I'll explain how to do it. But if you know about right triangles, you probably already know an idea of how to do it. So, we went through this, and what did we say cosine equals, so you don't have to go through the whole thing again? Can you just tell me, Mike? Tell me what was in your notes.
Notes of...
Does anyone have what it was, Casey?
It's R cosine theta of x.
Okay, and what did you have right before that? Cosine theta equals?
X over R.
There you go. Cosine theta is adjacent over hypotenuse. X divided by R, and then she got x by itself. And that's what we said x equals. In a second, we'll fill that in right there. Can someone else tell me what sine equals? Yep, sine is opposite divided by hypotenuse. Opposite is y, hypotenuse is r. We're going to do the same thing, get y by itself. Multiply both sides by r. Okay, you should have that in your notes. All right. And now we're going to fill in that box for y. So using right triangle trig, we're replacing x with an r and a theta, and we're replacing y with an r and a theta. I still have to explain how to calculate those two things, but I will in a second. So, fill them in, and you get what's in that box right there. That's the trig form of a complex number. So what would a final answer look like in trig form? You would calculate r, and you would calculate theta. I don't know, maybe theta comes out to 15. That is a final answer in trig form. In this case, it's the example where r happens to be 2, and your angle is 15 degrees. Your angle is not always 15. Your angle could be anything, but I'm just showing you an example. So, these two things you have to figure out. And this is just the same thing, 15. So r is the distance from the origin, and theta is the angle with the positive x-axis. So, let's see how we would find those two things. This is new. Okay, we haven't done this. Well, the method we're going to use isn't new, but I haven't shown you this in the notes yet. So, I want to find r first. What shape do you think I could make here that we make quite often in trig? We make a triangle. Now, x and y would be numbers. You would know them. Okay. Remember, when we graph something like that, it means to go 2 to the right and then 3 up. It's just like graphing a point 2, 3. So you will know x and y in a real problem. This is x, that's y. If you know x and y, how could you get r? Use the Pythagorean Theorem. I'm going to write that down very nicely in a second. So you don't have to write it yet because I'll put it on the next page. But to find r, you would use the Pythagorean Theorem. The other thing you need is theta. Well, if you want to know theta, and you know x and you know y, you can use a trig function. What trig function would involve opposite and adjacent? Tangent. So the tangent, we just said, is opposite over adjacent. You're going to know y and you're going to know x in a real problem. So tangent is opposite over adjacent. But that's not theta. That's tan theta. So how would we get rid of tan? We would use inverse tangent. Okay? So I'm going to write that out nicely for you on the next page. So to find r, we just said use the Pythagorean Theorem. To find theta, it's the inverse tangent, and I tried to just explain why, of y over x. Now, that formula works fine as long as you're in quadrants 1 and 4. If you're not, it's a very similar formula, but you have to remember to add something. What you add depends on, are you working in degrees? Are you working in radians? So to find theta in quadrants 2 and 3, it's 180 plus inverse tangent y over x. If you're working in radians, pi plus inverse tangent y over x. As far as Pythagorean Theorem, that works everywhere. There's no modification. To find r, you just use Pythagorean Theorem. Theta is the only one you've got to be a little careful with. Either use this formula or this formula. Now, those two formulas don't cover everything. Where else could you be besides in quadrants 1, 2, 3, or 4?
Imaginary.
Well, yeah, you could be at the origin, but then if your point was 0, 0, we'd have a problem because now we have to find the distance to the origin, which is 0 because it's right on the origin, and the angle is 0, so we wouldn't really have anything to work with. So I will never give you 0, 0. But where else could you be besides in a quadrant? Yeah?
4 points, 45 and 90, or not 45 and 90.
On an axis. Exactly. You could be on an axis. If you're on an axis, you just have to memorize the 4 numbers. 0, 90, 180, 270. There's no special formula to find theta if you're on an axis. Now, how can you know very quickly if a coordinate is on an axis? Coordinates on an axis always have what number in them?
0.
Always have a 0. 0, comma 1, 1, comma 0, 0, comma -5, -5, comma 0. They always have a 0. And zeros can be tricky because what math operation are you not allowed to do with a 0? You can't divide. Well, look at your formula. Your formula to calculate the angle has division. That's why this formula will not work if you're on an axis, because you could end up dividing by 0. Okay? So that's why if it's on an axis, you just have to memorize. If it's right, it's 0. If you went up, 90. If you went left, it's 180. If you went down, it's 270. Okay? And we're going to practice probably 3 or 4 of these kinds of questions as we go. Okay, so this one says find the trig form of, and it gives you a complex number in standard form. Real plus imaginary. Okay, first thing I'm going to do is graph it. Why am I going to graph it? Because the formula that I use to find theta depends on the quadrant I'm in. So I have to know how to graph this point and find the quadrant I'm in. Okay. Does anyone remember from Wednesday, how do we graph -2 plus 2i? 2 which way? Well, yeah, we start with the x-axis, or the horizontal, so 2 to the left, and then 2 up. So 2 to the left, 2 up. It doesn't have to be exact. We're not sketching this because I'm asking you to. We're just sketching it to make sure we know the quadrant. So what quadrant is that? We're in quadrant 2. Okay. That line that I just drew, that's my R. Okay. So keep in mind what we're looking for. When we're done, that's how the answer should look. But we need to find R and theta and just fill them in and then stop. Okay. Can someone remind me, what's my formula for theta if I am in the second quadrant? Well, AJ?
Y plus tangent, inverse tangent over y over x.
Can you say it again?
Pi plus inverse tangent.
All right, pi plus inverse tangent of y over x, exactly. Yep. I'm going to do it in degrees, so instead of pi, what am I going to use? I'm going to use 180. 180 plus inverse tangent y over x. So if you're like, well, which one is y and which one is x? It's in alphabetical order. X, then y. Okay, questions on the setup of the formula to find theta? Okay, Brandon, what's 2 divided by -2?
I'll go with 2. I'm not paying attention. Sorry.
2 divided by -2.
No.
What?
Divided by -2.
You know that.
I do. I'm going to theorem all day.
What?
Negative.
All right, someone help him out. What's 2 divided by -2? The questions are going to get a lot harder today. Yes, -1.
I was going to answer that question.
All right, so 180 plus inverse tangent of -1. You don't have to do that out, but for me, it's just less typing on the calculator. So if I can quickly say, okay, 2 divided by -2 is -1, I'm typing it in that way. And now I hit enter, and I get an angle of 135 degrees. Is 135 in the second quadrant? Yeah, the second quadrant is between 90 and 180. In fact, 135 is exactly halfway. And it should be, because this really is an isosceles triangle. You don't need to know that, but it is. Okay, so theta is 135. That's one of the 2 things we need. Okay, so we're going to fill that in for theta. The last thing I need is R. How do we find R? Pythagorean Theorem. Each side is 2. R squared equals 2 squared plus -2 squared. Mallory, what's 2 squared?
4.
And then -2 squared? 4. So we get R squared equals 8. R is the square root of 8, but we have to reduce that. If you don't remember how to reduce it, that's how you do it. Square root 4 times square root 2. And then the square root of 4 is something nice. What's the square root of 4? Matt? 2. Good. Okay. So at this point, we have everything we need to write the final answer. There's no more math to do. All you have to do is take R, take theta, fill them into that formula, and stop. Don't do anything else. So we get, for a final answer, I'll just put it up here. So it's R cosine 135 plus I sine 135. That's the final answer. You don't do anything with that. Okay? If you did something with that, you would change it back. Like if you said, well, what if I take the cosine of 135 and distribute what's on the outside? Don't do it. If you do, you're going to get this. So that's actually a good way to check your answer. If you want, take the cosine of 135 and distribute what's on the outside. You should get -2. Take the sine of 135, distribute what's on the outside. You should get +2. Okay? But we're not checking it. Okay, we're going to practice a couple more of those. Changing a number from this to trig form is necessary for everything in 8.4. You have to change things to trig form. Okay, so any question on how we got theta or how we got r? Okay, the nice thing is when you take the test, you can go back and watch it and see exactly how to do it. Okay, so the last thing that's on the test is once you have something in trig form, what can we do with it? Well, one thing we can do with numbers in trig form is we can multiply very fast, we can divide very fast, we can raise to powers, and we can take roots. Those are the last 4 things that I'm going to show you with the time we have left. Multiply, divide, raise to a power, take a root. Multiply is easy, divide is easy. Raise to a power is easy. Taking a root, it's time consuming. That's the hardest one. Okay, so what I've written here is just the generic form of a complex number. It's just trig form. When you do an actual problem, you're going to have all numbers, just like this. I'll let r be 5, I'll let r be 2 root 2. Okay, it's all going to be numbers. But to show you the process, I'm just going to pretend we have r1 and r2. It's my first radius and my second radius. In my problem, it's going to be 5 and 2 root 2 when we go through it. Each number has an angle. The angles don't have to be the same. Just like when you divide, you don't have to divide numbers that are the same. So in my problem, the first angle is going to be 0.93. The second one is going to be 2.36. For now, I'll just call them first angle, second angle. Theta 1, theta 2. So, to multiply 2 complex numbers in trig form, you have to do 2 calculations. You take these 2 numbers and you multiply them together. It's not hard. Don't worry. This is the easy one. Okay, you take r1 and r2, you multiply them together. The last calculation, you take theta 1 and theta 2 and you add them together. That's all you have to do. r1 and r2 multiply together, put that in front. Theta 1 and theta 2, add them together. That takes the place of doing something like this. If I was going to do that out, I would have to FOIL this all out. I would have to combine like terms. I would get I squareds, which we'd have to remember that's -1. And then I'd have to do all this stuff. We can forget about doing everything I just said, as long as you write your complex number in trig form. There's no foiling, there's no combining like terms, there's no I squareds, there's none of that. You do 2 calculations. Multiply your r's, add your angles. To divide them, what do you think you would do with your r1 and r2? You would divide them. And what do you think you would do with theta 1 and theta 2? You would subtract them. So that one saves us even more time because if you wanted to divide complex numbers without using this formula, you have to multiply top and bottom by the conjugate. We've talked about that. So now you have to find the conjugate, which is 8 plus 5i. 8 plus 5i. Now you have to FOIL it out in the top. You would have to FOIL it out in the bottom. Combine like terms, change all the I squareds to negative ones. It's going to take a long time to do division this way. It works. This way that I'm showing you now is a better way. All that stuff I just said, it all goes away. As long as you use trig form. That's the R and theta. Okay, so we're going to try probably one example of each. We'll do one example where we add, one example where we multiply, and then one where we divide. Does everyone have the two formulas? All right, let's start off with one that's a little nicer without decimals. And then we'll do one with decimals. Let's let Z1 be 3 cosine 40 plus I sine 40. Let's let Z2 be let's let it be 6 cosine 10 plus I sine 10. Okay, this is a highlighted example, so it's a good one to know. Okay, first thing it says is to multiply them together. Old way, you're thinking foiling, I squareds, all that. New way, it all goes away. What's my radius going to be when I multiply these together? 18. We're halfway done. So there's my radius. What is going to be my angle? 50. And you're done. All that took the place of the foiling and all the other stuff I said, and that's the answer. And that's it. You don't do anything else with that. So any questions on how to multiply two complex numbers in trig form? Okay, let's try dividing. Okay, when I divide them, it's important you focus on the order. This is Z1 divided by Z2. So what's going to be my radius? 1/2. 3 divided by 6. Okay. What's going to be my angle? 30. And you're done. That's how you divide two complex numbers using trig form. No conjugates, foiling, no I squareds, much, much easier. Any questions on how to multiply and divide in trig form? Okay, so I told you there's 4 things I'm going to have you do. I just taught you half of them. Those 2 are easy. The next one is just as easy. The last one, it's a little harder. Okay, you don't have to do that homework. So there is no homework in the book for anything we do today. So last 2 things I'm going to show you are how to raise a number to a power, and the opposite of that, which is taking a root. Now, why do we want a shortcut to raise something to a power? Let's pretend you didn't have the shortcut. Let me show you, even with small numbers, what happens. Let's say you wanted to cube 2 plus 3i, the old way. Okay, not using trig form. I'm using standard form. Watch what I have to do. I have to write it out 3 times. And now I have to FOIL everything. Foiling is not that bad. I can do it pretty quick, but I get 2 times 2 is 4. 2 times 3 is 6i. 2 times 3 again is another 6i. And 3i times 3i is 9i squared. But what is I squared?
-1.
It's -1. Okay. And I got some like terms. 4 minus 9 gives me how much?
-5.
-5. Okay, so that's what you get. As long as I didn't make any mistakes, I don't think I did. That's what you get when you multiply the first two together. Now you have to do it again. I'm not going to go through it, but once you do it one more time, that would be your answer to cubing it. Not that bad. If I did it out, I could probably do this all in under 60 seconds. Okay. Now, if you asked me to do 2 plus 3i to the 9th, well, now it's probably going to take me 4 or 5 minutes to make sure I do it right. And then if you ask me to do 2 plus 3i to the 95th power, I can't do that this way. This is just way, way too long. There's hundreds, maybe thousands of multiplications I'd have to do. I'm going to make a mistake somewhere. So this formula that I'm going to show you, it would take the same amount of time to do that problem, or that problem. Doesn't really matter what power you raise it to. But the trick is we can't use standard form. How do you think I'm going to write this number instead of standard form? I'm going to write it in trig form. Write it in trig form. All right, so if you write it in trig form, okay, you would have something like r cosine theta plus I sine theta. Okay, that's what we just talked about. And we're going to take and raise that to a power. N could be to the 3rd power, it could be to the 5th power, n could be any integer that you want. So, to raise this number to a power, instead of having to do all the foiling I just showed you, and the I squares, -1s, and combining like terms, you only have to do 2 things. You take the radius and raise it to the power. And that's an easy calculation, you just use your calculator. Whatever the radius is, raise it to the power. Last calculation, take your angle and multiply it by the power. And theta. And that's it. That's all you have to do to raise a number to a power. Raise the radius to the power, multiply the angle by the power. What's not hard is the process. It's remembering, wait, do I add the angles, do I subtract the angles, or do I multiply? You've seen all 3 now. But you can look it up in your book or use a reference sheet, however you want to do it as you're taking the test. So memory or memorization shouldn't really be an issue, which formula is which. Okay? You've got the formula in the video. Okay, so let's try an example. I'm going to do example 2 first. So hold off on copying that. Actually, you know what? No, let's do that one first. So I want to cube that. What's wrong with wanting to cube that using DeMoivre's theorem? Why can't I use that shortcut the way this problem is written?
Oh, imaginary.
What's wrong with the way the problem was given to you?
It's not in
It's not in trig form. What is that?
standard.
Standard. Standard's great for when you're first learning, but it's not really not that great when you have to do calculations. Trig form is a lot faster. The longest part of this problem is going to be changing this to trig form. Cubing it, once we have that, is super easy. But let's change it to trig form, and the question says use degrees. Okay. So what are the 2 things you need to write a number in trig form? Yep,
theta and r.
exactly. We need theta and we need r. So when I'm done, I'm going to fill that in with r and theta. Let's make our sketch. +1, positive root 3. Ezekiel, what quadrant is that? Quadrant 1. Positive, positive. It doesn't matter if it's +7 or +7 million. It's positive. Positive, positive, somewhere in quadrant 1. Your sketch does not have to be exact. Okay. So, this side is 1. That side is square root of 3. How would I get my radius? Use the Pythagorean Theorem. R squared equals x squared plus y squared. So r squared equals 4. 1 squared is 1. Square root of 3 squared, 3. So what's my radius? 2. Okay. So we've got half of what we need. We've got r. Now I need to find theta. What's my formula for theta if I'm in quadrant 1? Yep.
It's the inverse tangent of y, right?
Inverse tangent of y over x. In this case, x is just a 1, so you really don't even need it. So it's inverse tangent of square root of 3. 60 degrees. Thanks. Theta, 60 degrees. Okay, so let's fill that in and see what we got. So we got 2 cosine 60 plus I sine 60. So we've just converted from standard to trig form. And then what power am I raising this to? Third. Okay, so now just follow the formula. So in the formula, our radius is 2, our theta is 60. We'll get back to that. So, tell me, what's the first thing I need to do once I get back to the page? What's the first calculation? Yep.
You raise 2 to the third power.
Take 2, raise it to the third power. And then what about our angle?
Multiply by 3.
Take your angle times your power. What's 60 times 3? 180 plus I sine 180. With the exception of doing out 2 cubed, that's your final answer. Cosine 180 plus I sine 180. That is how you raise a complex number to a power. That part was very fast. If you asked me to do it to the 20th power, I could have done it just as quick. 2 to the 20th, use my calculator. 60 times 20, no problem. If you want me to do that in standard form, it's going to take forever to FOIL out all the parentheses. That's what this is good for. So any questions on raising a complex number to a power? So, in that problem, let me go to the next page by hand. What did we just do? We cubed a number. Right? What's the opposite of cubing? No.
Cube root.
What is it?
Cube root.
A cube root. The opposite of cubing is a cube root. The opposite of squaring is a square root. So, what we're going to look at now is how we can take a root. So I can go back. Or not. I'm going to show you how to find a root. Okay, I have all the steps written out. I think it's going to be kind of confusing if I write them all out. It's probably going to be easier if I just show you an example, and then you have something to follow. If after somebody wants to see all the steps written, there's like 4 steps, I can write them all out. Okay, so we're going to find the cube roots of this number. All right, the first step is make sure it's in trig form. Is that trig form?
Yes.
Yes, that is trig form. Okay, so that's step 1. Let's pretend that this complex number is x. Just for now, I just want to name it with a single letter. Okay, that whole thing is going to be called x. What I'm going to do is write this. So you start by writing z to whatever power you're going to find. If they told me to find the 4th roots, I would put a z to the 4th there. If they told me to find the 5th roots, I would put a z to the 5th. They asked me to find the cube roots, so I'm going to put z cubed. The right-hand side is going to be this. It's what we have up above, 27 cosine 100 plus I sine 100. This is going to be a 3. What you always plug in for z, doesn't matter if you're finding cube roots, 4th roots, 5th roots, any roots. Always let z equal the following. R cosine theta plus I sine theta. That is always what you plug in for z. R cosine theta plus I sine theta. Now, there's not much we can really do on the right-hand side, but we can do out the left-hand side. That's DeMoivre's theorem, raising this to the 3rd power. So if I want to cube what's in parentheses on the left, what's the first thing I would do? Yep.
Cube R.
Cube R. I'm not going to get a numerical answer for that. I'm just going to get R cubed. And then, what about my angle? Multiply it by 3. Okay, so that's the left. And then the right, it just stays the same the whole time. So 27 cosine 100, I sine 100. Now, between the left side and the right side, what symbol do you see? What's separating the left side from the right side? Equal sign. Equals means what's on the left has to match what's on the right. So there's 2 things that have to match. There's a radius on the left. There's a radius on the right. Somehow you have to find a number for r so that when you cube it, you get 27.
3.
It's going to be 3, yeah. So that's the first thing. I'll set that up in a second. The next thing you have to set up is the angle in that box has to match the angle in that box. That's what equals means. So the radius has to match the radius, and the angle has to match the angle. Okay, so let's set up the 2 equations you would solve. First one, the radius on the left equals the radius on the right. And then we solve it. How would I get rid of cubing r? Take the cube root of each side. Cube root, cube root. And as Mina just said, r is 3. So we have our radius. And the angle. Okay, the angle is a little trickier than the radius. So, the angle on the left equals the angle on the right, or it can equal anything that is what we call coterminal with it. Okay? Does anybody remember what was the period of cosine? How much to go one full cycle? How many degrees? 2 pi, or in degrees?
It's 5 degrees.
Pi is 180.
So 90. No,
360. So, remember before when we solved trig equations, we had to put plus 2 pi n because there were multiple answers? That's what you have to put here. Plus 360 n. And now, how would you get theta by itself? What would you have to divide each side by? Yep. Divide everything by 3. 3, 3, 3. And now you have a formula for theta. It's 100, let's just call 100 divided by 3, let's just say 33.3. 33.3 plus 120 n. So now, these are the two things that we use to write our answers. Okay, as far as like the difficult calculations, those are done. So n is a variable. So n has to take on a number. Right? That's what variables do. You plug in numbers for them. So let n equal. If you take a square root, for example, square root of 4. What's the answer to the square root of 4? 2 and negative 2. So how many answers are there for a square root? 2. You always have as many answers as the root you're taking. Square roots have 2. Cube roots would have 3. So when you write your final answer, you are going to have 3 answers to this question. If I asked you for a 5th root, you would have to find 5 answers. 7th root, 7. I'm not going to ask you for that. Okay, I'm probably going to ask you for up to maybe a 4th root, not any higher than that. The 3 numbers that you let n equal, because you have to let n equal 3 values to get 3 answers. 0, 1, 2. Those are the 3 numbers you let n equal. 0, 1, and 2. So, we're going to write our 3 answers. They're all going to be in trig form. Okay, we're not going to write them in standard form. You start with r in the front. R is going to be the same in every answer. The radius is 3. 3, 3. It's always 3. Then I like to fill out all this stuff. So what I'm doing is I'm just making a template for where I'm going to fill in all my answers. And now what you're going to put in the blanks is what you get when n equals 0, 1, and then 2. Okay. So this will be n equals 0, n equals 1, n equals 2. Let's start with 0. What's 120 times 0? 0 plus 33? That's your first answer, 33.3. Let's let n equal 1. What's 120 times 1? 120 plus 33.3. 153.3, that's your second answer. Okay. What's the last number I said to let n equal? 2. What's 120 times 2? 240. Plus 33.3. 273.3. Those are my answers. Okay, as I said, that one's not quite as easy, but I'm going to do the same thing again. I'm going to do a 4 through. I'm going to try to pick one that doesn't have decimals if I can make one up without decimals. I just have to think of a number that's divisible by 4 nicely. Okay. I'm not going to ask if there's any questions because I'm going to do another one first. But does everybody at least have that one copied? Okay. So let's find. Let's do the 4th roots of. Let's find 4th roots of 16 cosine 200 plus I sine 200. Okay, the first step is just to write down the equation. Anyone? Well, we're going to put x on the right. Does anyone remember what goes on the left to start? Just a single letter to a power. Z to the 4th. Okay. Hannah, question? This is really hard, so please pay attention or don't talk so other people can try to focus too, okay? Unless you have a question. So, z to the 4th equals x. Now, what did I say you let z equal? 2. 2? I can't go back the other page, otherwise I'd show you. I said let z equal. Yeah?
R cosine theta plus my sine theta.
Yep. Let z equal r cosine theta, I sine theta. I think I used brackets. It doesn't matter whether you use brackets, parentheses. Okay. On the other side, you're going to fill in the original problem. 16 cosine 200 plus I sine 200. How do I do out the left-hand side? What's the first thing I do? R to the 4th. Yep. Cosine 4 times theta. And that's it for the left. Now keep the right exactly the same. So 16 cosine 200 plus I sine 200. Okay, now I'm going to set up my two equations. What on the left should equal what on the right?
R to the 4th should equal 16.
R to the 4th should equal 16. That's the easy one. That's the quick one. Take the 4th root of each side. What's the 4th root of 16?
4 theta should equal 200 degrees.
1 second. What's the 4th root of 16 first? 2. So when we write all 4 answers, they're all going to start with a 2. Now we just need to figure out the 4 angles we're going to plug in. Can you go ahead, Josh? Tell me what the other equation is?
4 pi equals 200. And pi theta.
4 theta equals 200. What do we have to put on the end?
Plus 360n.
Yes. So plus 360n. Okay. What would I do next? Yeah?
Divide everything by 4.
Divide by 4. So that's your formula for theta. This time, no decimals, I don't think. What's 200 divided by 4? 50. And 360 divided by 4? 90. We're finding a 4th root I already gave you a hint, but how many answers are there going to be? 4. What are the numbers we're going to let n equal? 0, 1, 2, 3. That's how you get your 4 answers. So once you do that, this is more just kind of repetitive than anything else. Okay, first answer. What's 90 times 0? Plus 50? 50. 50? 50. Next one, n equals 1. 90 times 1? 90. And Mike, 90 plus 50? 140. 40? 140. Next one, n equals 2. Wyatt, what's 90 times 2? 180. And then plus 50. 230. 230. 230. Last one, n equals 3. Matt, what's 90 times 3?
207.
Plus 50.
320.
320. And those are your 4 answers. Okay, the problem on the test will not be more than 4. My advice would be, as you do that, try to either watch the video or look at the example in your notes and follow along. Cube roots, fourth roots, roots are the hardest ones. How many people check their email? So some of you know what's going on. For those of you that didn't, I would just make sure you read that. It's also attached to the last page of your test. So, the test is going to be a take-home. Okay, on the take-home, you can use book, notebook, calculator, internet, anything you want except each other. Okay, if you are caught working with anybody, you will get a 0. Make sure you show all your work. Okay, there are no multiple choice questions on the take-home. They are all short answers.
How many questions?
10. 10 short answers. If you get an answer right, but there's no work to show how you got it, I mean, you can just look up law of cosines calculator on the internet and look up all the answers. You won't get any credit. So you have to show me your work. If there's not enough room, I try to leave room, but I use another piece of paper. The test is due at 8 a.m. on Monday. 8 a.m. Monday. You will have to come see me. If you are on co-op, make sure you email it to me before 8 a.m. If it gets to me at 8:05, it's a 0. Okay? You have today, you have Saturday, you have Sunday. Don't wait till like 7:30 Monday morning to start it. You will not finish. Yes. You can also come up and give it to me in person Monday morning. Do not leave it under my desk or under my door or under my desk either. If you say something like, Mr. Hager, I put it under your door, it's not there, then it's a 0. So give it to me personally. Don't leave it under the door. Also, if you have any questions, I will check my Monitech email tomorrow at 11 a.m. So if you have any questions, you can email me. I will get back to you. If you email me after 11 a.m. tomorrow, then I will be checking my email. So if you have a question, you have about 24 hours to ask me. Okay, on the test, I need to change the directions for one of the questions. Okay, first of all, number 7 is a bonus. Number 7 is a bonus. Number 9. Leave your answer in trig form. The directions on the test say to put it in standard form. Don't do that. Leave your answer in trig form.